us using Ecker's minutes tool, or does somebody want to take notes? Okay, most thumbs up to Ecker, and cut your head off to taking notes. So unless somebody disagrees, I'll call that consensus. Marius, do you agree? Hello, Marius. Good morning.
Hello, everyone.
Hello. All right. We have most of our presenters here. It's actually a fairly good turnout for this meeting, despite us having an enormous room. I'm not sure we needed an auditorium. I feel like maybe I should do a song and dance routine while I'm up here, but I won't subject you to that. All right. Hold on. I think, did I unshare the slides? I think I must have when I reloaded. Yes. All right. Let me put the share slides back. All right. Hello, everybody. Welcome to AVTCORE. This session is being recorded. I am your co-chair, Jonathan Lennox, and remotely here we have Marius Kleidl. All right. So first thing, of course, is the note well. By participating in the IETF, you have agreed to follow IETF processes and policies. There's a QR code here to remind you of if you need more information about these processes and policies, but notably is we have an anti-harassment policy, so please treat everybody with dignity and respect and behave in a professional manner. And if you feel like these are being violated, please contact the chairs or the ombuds team or the ADs as appropriate. If there's IPR policies, please be aware of your obligations under that and declare any IPR you're required to declare, which is, I won't explain the details here because it's complicated, but please understand that and comply with it. What else? Yeah, and then we do have, this is being recorded, so you will appear on the audio and video of the session. All right, meeting tips. If you're in the room, please sign in to Meetico, either from the agenda or via one of the QR codes in the room, or there might be other ways, but those are the two I know about. You can use the light client if you just want to join the queue and see the slides, or you can use the full client if you also want to see video, or if we happen to do any screen sharing. But please make sure to keep your audio and video off unless you're sharing or presenting or talking to this session. And if you're in the room and you join the full client, make sure to turn audio playback off using the volume control at the bottom. If you're remote, use of a headset is strongly recommended because echo cancellation is good but not perfect. And everybody, please state your name each time you begin speaking, because the recording does not show the queue, so we won't be able to use that after the fact to see who's recording, so please always say who you are. Here are some resources. You can click on them. I probably know all of these already. And here's our agenda for the day. Yeah, we're doing first APV, and then H265, the ARF, RDB frame acknowledgements, S-frame, and then at the end we have two things that are not strictly speaking in our charter, but we're probably the closest working group that's still meeting. They're both sort of related to WebRTC space enhancements. So we'll be presenting those. One of those, I think we said that one of them is going to be Justin and one of them is going to be Philip, but I don't see Justin. Oh, no, Justin is here. Good. Justin's here now. So yeah, so Justin will be presenting one. And is this the order you want, Philip, for those? I know you were saying in one order.
Yes, that order works. Thank you.
Wonderful, great, thank you. Okay, and then here is our draft status. We have 2 documents with the RFC editor. 2 that have completed working group last call, 1 for which I say, Shepard, write up in progress, which might be a little bit optimistic, but I think, Marius, you said you thought it'd be simple, so you could do the Shepard, take the Shepard on that? Yeah, that should be a simple one. Green metadata is currently doing a working group last call, so please, if you haven't sent in your opinion on that yet, please read it and review it and send in any comments on it. We have a number of adopted drafts, some of which we're talking about today, some of which we aren't, and 2 newly adopted drafts, which I think we're talking about both today, but I've lost track. But anyway, so our first presentation will be APV. So, okay, you are here in person, great. So let me switch the slide deck. And do you want to use the clicker, or do you want me to drive this to control the slide? All right, let's see. I think I have to, yes, transfer slide control to the clicker, and this should now work.
Yep.
Okay.
Is it working?
You probably want the microphone higher and make sure it's turned on.
Hey.
There we go. That sounds good.
It's better.
Yeah.
Okay, thank you. So this is payload format for APV. So as mentioned, it's just newly adapted. I just want to go over again, basic concept of the draft, so that I can get more comments or complaint, whatever to me. Okay, so APV, just as a reminder, if you haven't heard about it, it's a kind of video codec for professional use. Professional use mainly means that you are not, you are thinking about to record, encode video once, and then edit it and then decode it, encode it again. So there's a kind of multiple decoding, encoding, decoding, encoding, kind of re-encoding step will happen with that, bitstream. So that means you need to try to preserve the content throughout that, the re-encoding step, and so on. It has been, proposed as an information RFC, and then now it has been published as RFC 9924. Thank you for everybody who has a kind of, provide a good feedback about the draft. And then this draft is about, payload format of that. So I need to introduce, what's the kind of, bitstream structure of the video encoded bitstream. So it's a very simple structure, AU, common term used by kind of, most of video codecs, same as, here that, it's a, one instance of the same time. So access unit is composed of series of, PVU, data unit. So there could be more than one PVU inside the AU. You can put whatever you like. So that the kind of AU size, so that you can keep counting how many bits has passed, or how many PBU is there. And then PBU is constructed as PBU size, header, and data. So size tells you how many bits, and then type is in the PBU header to tell you what kind of data in the PBU. So you can see the kind of detail in the RFC 9924. So it's mainly saying that it's a kind of video data. I will explain a little more, or the kind of metadata. And then in for the video data, you can have a main video. And since we are talking about more of the professional video codec, so there could be a case that you have a small size of a thumbnail kind of thing, so you don't have to decode everything to see kind of what's in there. And then you can have multiple frames with a different angle, so that you can have a multi-view content and so on. So those are kind of main different type of PVU. And then so we expect that a lot of case you will see this kind of PVU, which is encoding the frame data, actual video frame, not the metadata or and so on. So if you encode video, then that's mainly subdivided into multiple tiles. And each tile data will be encoded as a PVU type something. And then you will have a frame header repeated for each tile. And then you will see the kind of tile size, tile data, tile size, tile data, combinations. And then at the end, you can have a kind of filler data and so on. So this is a kind of, video coding data. I mean, mainly you will see the tile as a, smallest thing you will see in there as a bitstream. And then, you will see that, tile series of tiles in, is, packed as a kind of PVU, then multiple PVU becomes a one, AU. So as you can easily imagine that, the, payload format mainly talk about how to generate the payload out of that, video bitstream, AU bitstream. And there are two ways we are providing in this, draft. The first one is simple mode, which means that, it should be simple for fragmentation. I mean, simple for packetization and depacketization. That means you don't really care about, what's inside, and you just kind of whatever your MTU size or kind of remaining bit budget for the kind of payload, you just kind of chop it and send it. So there's nothing other than AU boundary. So each AU will start at the, first of the payload. Other than that, nothing will be kind of, restricted. Second way is low delay mode. If you want to start decoding immediately whenever you have, for kind of payload or packet, which means that kind of some of the boundary must be aligned with the kind of payload start. So in here, we say that, the beginning of tile size field, you saw that, kind of mostly we'll have a kind of PBU with the tiles inside. So, we're not talking about the PBU header, PBU start, but, tile start should be aligned with the payload header so that, each individual tile can be kind of, received easily and then discovered easily, so that your, decoding latency would be kind of simplified. I mean, or delay, minimize. Payload header usage, packet header usage is very simple and very, straightforward because, it's not, it doesn't have a kind of, the temporal coding, like it doesn't have a P frame or B frame. It's just kind of everything is I frame. So, whatever you need to indicate in the header is just kind of capture time. Usually, we use a kind of 90 kilohertz for timestamp. And payload header size, you only provide, what's the your payload packetization mode is a simple mode or a low delay mode, and you will have counter that how many packets you need to receive to get back the original data sent by the sender as one thing, right? So in the operation mode, you will see that what's the kind of mode, and then you will have a payload type indication saying that where you are the start of the payload fragment or end of fragment or in the middle of something. Yep, and this one is more about that the frame header is repeated or not. So as I mentioned that in the simple mode you are aligning the start of tile header, and then you need to have a frame header to decode that part of tile. So you can optionally repeat the frame header at each kind of tile header. I mean tile size appears. Okay. And then you can also say that the frame header is static, so you have multiple frames going on, but each frame has the same frame header, and so on. Yep.
Just a quick suggestion. I would try to avoid any fields names that collide with the RTP header. So calling something payload type may be horribly confusing.
Okay. Okay. Good suggestion. Maybe I will call this APV, payload type or something like that.
For format or
Yeah.
And also for consistency, whether you use access units or frames, pick one and then go with it.
Okay. Yeah. That's a good suggestion. Thank you. So media type registration, we're thinking about, register one type of APV. Mainly we need to indicate profile, level, and the band. Band is a little bit of, further specifying levels because, so there's huge range of levels. So you might want to have a kind of little bit more, band inside. SDP, we don't think, this, codec will be used any kind of, bidirectional communication purpose. So our SDP parameter section simply say that you announce this one, and then you are not expecting any feedback or negotiation and so on in that section. I think that's it. And this has been adopted as a working group item. So I expect more comments, complaints, or criticism, whatever. We'll be happy to get receive this one and then get going. And I don't think I have a GitHub repository yet for this one, but I don't know whether we actually need it or not.
Yeah, I mean, it's up to you. If you'd rather not work on a GitHub model, that's fine.
Okay.
So I have one comment as an individual, which I'm afraid just occurred to me now, or I would have emailed you about it. So what kind of packet rate are you expecting for this?
Several hundred megabits.
Yeah, because so with some previous payload formats that are intended for extremely high packet rates, they've added an extended sequence number because there's a worry that you can actually loop the 2 to the 16th packets within the time packets might be expected to linger in the network.
Okay.
So if that's the case, you might need to look at, I think, for example, the RTP payload format for uncompressed video, which is obviously the worst case.
Okay.
Which is
That's also a good suggestion.
4175.
Yeah. Let me simulate the numbers, and if there's a often wrap around, then definitely we need to increase.
That sounds good.
Okay. Yeah. Sounds good. Thank you. Yeah.
All right. Anybody else have any comments on this?
Please.
Yeah. All right. Sounds good.
Thank you.
Thank you. All right. So let's see. How do I do this? Do I have to first I take back slide control, I think, and then I stop the slides, and then I start new slides. It's all very complicated. Now H.265, I think. And Philip, I think I can hand you slide control if you want, Philip, or do you want me to drive it?
If you could drive, that would be good. It's just one slide.
I'll drive. Okay.
Good, thank you.
All right.
Okay, it's been a while since the last update. Bernard Abova was the driving force behind this draft, and he passed away last February. I would like to welcome Jialin from Intel as co-author. He's been driving the implementation of this in Chrome, so I think he deserves to be co-author. This is mostly a status update. All previous open issues were resolved. If you want to look at what happened, this is in PR 33 on GitHub. HEVC in WebRTC has shipped both in Chrome 136, hardware only, and in Safari 18. We do have RPSI specified, which is a change since the last version, but it's not implemented in browsers. We do have it specified, so we should be good on that front. If browsers ever add support for that, they know how to behave. I think the ask for the working group is if there are any open issues that we should be dealing with before moving this forward. I found one issue in the introduction, but that was mostly NITs. Any questions or comments?
Mo?
I'm assuming that in the WebRTC use case, you're doing in-band parameter sets on all of the keyframes, correct?
Correct.
The one issue that we opened because of mock was we discovered that for web codecs, when you specify HEVC, you don't get in-band parameter sets, even though there is a specification for it. It says if you use this particular type, I forget whether it's HEVC1 or HEV1, one of those two is supposed to be in-band, but yet you don't get it. I assume that's not going to be a problem for this because you're just going to always hard code in-band parameter sets all the time.
Yes.
Okay. So I guess it just be more of an issue to open up in the web codecs W3C issue tracker instead.
Yes.
All right. So I mean, I would suggest then if just publish a new version with fixing the nits you had in the introduction, and then sounds like we're ready for working group last call.
Will do. Thank you.
Okay, great. Thank you. We're moving on at a nice clip today. So we should have plenty of time for the stuff at the end, so which is always nice. And what's next should be avatars, right? So, yeah, okay. ARF. No, ARF. Yeah, okay. So, all right. Do you want? Okay, so all right. I'll give control to the clicker. Okay, you should have slide control now. Should have slide control now. Is it not working? It says the clicker has slide control. Huh? Has the battery died? I'll pick. So let's see. I can run the slides, and let me take another run. Okay.
Yes.
Go ahead.
Next slide, please. Yeah. So this is our outline of the today. Next slide, please. Yeah. So these slides briefly summarize the history and the recent update of the Avatar draft. First of all, thanks to everyone who support working group adoption call. So based on that, the document has been updated as a working group draft, and we also made a small change to the title by adding the word stream to better reflect the scope of this draft. Next slide, please. And then we also had many discussions with people who are involved in MPAC group. So based on that discussions, we also update abstract and the introduction so that the terminology is better aligned with MPAC specifications. Next slide, please. And in addition, we also add some reference to clarify the original sources. Next slide, please. And for another part is related to the Avatar animation unit. So we expect that Avatar animation unit may be updated depending on the outcome of next MPAC meeting. So we are planning to update payload header sections based on that discussions. So we will update it. Next slide, please. Yeah, so always suggestion and feedback are welcome. And as I mentioned, we are planning to update draft and eventually recast working Rust code when MPAC start FDIS process of the Avatar.
Is there roughly a timeline of that? Do you know?
Pardon?
Do you know roughly when that's likely to be?
I'm not sure.
You don't know? You don't know?
Yeah.
Okay, that's fine. I'm just wondering if they had any timelines on their side, how soon they thought that would be, or if it's when they're done.
Yeah, as I know, this is DTI stage. So, and then, yeah.
Okay, that's fine.
Yeah.
So yes, so sounds like you have a good plan. So, anybody have any comments? Otherwise, sounds good. And I guess let us know when they've reached FDIS, and we'll proceed. Sounds good. Thank you.
Thank you.
All right. Next up is Let me make sure I have the right version of your slides. This should be version 2. Let's see if we have the clicker working now. All right, see if that works now. It's still not working. Very strange. All right. All right, I'll drive the slides.
Okay, thank you. Good afternoon, everyone. I'm Gurtej from Apple, and me along with Eric and Sridhar, we are the authors of RTP Frame Acknowledgement. So the background here is this is a mechanism through which um, a video sender can find out about like frames not being decoded or being lost, so that it can encode the subsequent frames with a well-known reference which it knows that the receiver has decoded. So this helps us like not it prevents like large keyframes required to be sent like when there is loss, and you can recover quicker from that loss. So can you go to the next slide, please? So this draft has not yet been adopted, but the authors have been making progress on GitHub. We have 9 open issues and 15 of them have been closed. So quite a lot of progress have been made since last IETF. I wanted to go over some notable topics. So maybe let's go to the next slide, please. So the first thing that we added, and we discussed this at the previous IETF, is we added a mechanism to have receiver triggered resynchronization requests. So so say if the receiver notices that its decoder is being starved, frames are coming in, but it's not able to decode it because it does not have the reference, it can wait for some timeout and then requests a resync. We to account for this, we've updated the feedback format to contain like 1 byte flag field. Right now, only 1 bit is being used in that, which is this R flag, which represents a resync request. So this can be like an unsolicited feed RTCP message that can be triggered from the receiver to the sender, and it can contain like the last decoded frame ID and the status vector up to the last received frame. And then the sender can encode the next frame, referencing the frames available at the receiver using the status vector.
York, did you have a question?
Yeah, Jörg, thank you. I'm curious. So we have RFC 4585 that defines reference picture selection indication, which allows you to precisely point to which frame you should be using as a reference for subsequent encoding after a frame has been lost. This seems to be providing similar functionality. And I'm wondering whether there are specific things you have in mind that aren't covered by this past document, or whether I just didn't have a chance to read this. I come across this first time now. This is why I'm just curious.
Yes.
So please enlighten me on that.
Yeah. So we also have Eric here who can chime in, but my understanding is that the RPSI draft is not being implemented for some of the newer codecs like AV1, AV2.
But it's orthogonal to the codec, I think.
It is specified in the payload format, I think. Yeah.
Yeah, RPSI specifies what you select based on internal codec details. This is intended to be codec independent.
Okay, codec independent is clearly good, even though RPSI is partly codec independent.
Yeah.
It's not specific to a certain one. Yeah. I was just curious.
Yeah.
Yes.
If there is a similar design in spirit, then maybe that should be following a similar structure, if that helps to make implementations easier to carry over. Thank you.
Okay, we can go to the next slide, please.
Sure.
So we've also added a section for SDP negotiation. So we defined an extension map attribute for the new RTP header extension. This is how the sender marks frames and expresses to the receiver that it cares about feedback for those frames. And we also added a new RTCP feedback attribute for the RTCP feedback message that you saw in the previous slide. The feedback message attribute also has like a parameter called resync timeout, through which the sender and receiver can know about like use case specific timeouts. So for certain low latency applications, you might want to be more aggressive on the receiver side while requesting these the resync requests, and the sender can plan its feedback cadence in accordance to that as well, requested feedback cadence. So next slide, please. So next, I wanted to kind of just go over some examples, and these are also we've also added these to the draft to explain some of the different modalities of the feedback request and the feedback mechanism. So the first example is the sender is transmitting several frames, and then it requests feedback to confirm which frames have been decoded at the media receiver. So here, if you can see, the sender sent 3 frames, timestamp 0, 100, 200, with frame IDs marked as 0, 1, and 2 in the extensions. And it just was marking the frame IDs. It did not request any feedback at that point. When it sent the 4th frame, it marked it with frame ID 3, but also set the FFR field to 10, which implies that it is requesting feedback, and it provides the range. So it can start from frame ID 0 with length 4. So it basically saying requesting a range of 0 to 3. And the media receiver responds to that with a status vector. Here in this case, vector is all ones because all 4 frames were received. So this is the simplest case. Next slide, please. So this is just another variant where the just showing that you might have several frames where you don't even tag them with a frame ID. So you just send them without any RTP extension, without the specific RTP header extension. And then it sent a 4th frame with some ID 4 in this case. And it also set the FFR field to 0, 1, which implies that it's implicitly requesting feedback for this frame. And the media receiver responded to it with just feedback of length 1, vector 1, because it received the feedback. Next slide, please. Okay, so now this is a kind of showing like how you can recover from frame loss. So we have like 2 modalities here. One is like a sender side recovery mechanism. So here what we're showing is the sender just keeps with every frame ID, that it marks, it keeps requesting the feedback for the last 3 frame IDs. So in this case, the example starts like from the frame ID 10, but there were 2 frames before this. So the media receiver responds with the feedback saying, yes, I've received all 3, status vector 1, 1, 1. All of them have been decoded. Next slide, please. Okay, so the next frame, let's assume it's like fully lost in transit. And next slide, please. When the sender sets the next frame, again, as always, it's requesting the feedback for that frame and the previous 3 frames. The receiver will respond with status vector 100 saying that I did receive frame ID 10 or timestamp 1000, and the 2 frames after that, either I've not received completely or I have received them but I have not been able to decode them. Both of those are currently represented as a 0 in the vector. So it's responding with 100. So at this point, the sender, once it receives this feedback, it can encode its next frame with the known reference, which would in this case be the first frame with timestamp 1000, and the receiver will be able to decode that frame. Next slide, please. Thank you. This is showing the receiver triggered resync request that we kind of talked about earlier. So here again, first frame ID frame was sent, and the implicit feedback was requested for it. The receiver immediately responded with, yes, I've decoded it. Next slide, please. Let's say it received the next frame, but it was not complete. It could not be recovered through FEC or other RTX, other mechanisms. So it was only partially received, so it could not be decoded. Next slide, please. It received another frame. This was fully received, but it was like referencing the previous frame, so it cannot be decoded. So then after a timeout, the receiver can decide, okay, like my decoder has been starved for too long. I'm going to request a resync request, which is what it does, and it in that indicates that I did receive frame with identifier 20, which was the first frame in this flow, and with the status vector of length 1 and value 1. And then next slide, please. And the sender is then able to decode the next, encode the next frame using the known, well-known frame as the reference, and then decode can continue. Next slide, please. So, as next steps, we want to keep like making progress on the remaining GitHub issues that we have. We're happy to get like more eyes on this, and we're happy to address any feedback that you have. Also, at this point, I think we think that the draft is in a state where the main structure is there, and we would like to call for adoption. We think this work is very relevant to this working group.
Mo?
Yeah, I think the goal is admirable to have a general mechanism, but I think the reason why RPSI is codec specific, because when you get into the details, you realize that you can't do this in general for any codec. The codec has to have explicit support for long-term reference frames, and you have to say, how do you mark the long-term reference frames? And when you say rewind to this other reference frame, you can't use an RTP timestamp. You have to refer to the codec's internal frame ID. So then you have to have these bindings between your generic message and the individual codecs that actually support it. And then how do you map those frame IDs and the support for long-term reference frames and things like that. So it almost seems like you still need a binding of this to AV1, 264, 5, and everything else.
Yes. I think the binding is required in the software on the sender and the receiver, but this provides like a generic mechanism on the wire, which once you have the bindings, it can work across any codec.
Are you planning to put like common bindings for common codecs into this spec, or do you plan another spec to show those bindings?
No, we are not planning to put it in this spec, but we can discuss that. That's valid feedback. Perhaps like in the future, as like new codecs come in, or with old codecs, we can discuss enhancing those.
Altanay?
Wait, sorry. Did I unmute? Yeah. Hi, Altanay Kumaraki. What do you think is the potential for amplification attacks when somebody is requesting a large window of frames? Because that's basically just going to overrun the budget for data.
Can you repeat that? So like what's the attack
So
vector
if you
here?
go to the if you go to the diagrams, let's go to the first diagram that you showed me, this first sequence diagram. Okay, so
Sorry, let me find
first
this
sequence
slide.
diagram, please.
That's
Yes,
what I
yes.
think.
Any is good. Okay, let's wait on this. So this one shows FB start 0, FB length 4, right?
Yeah.
Let's put FB length end length to maximum. Then it's the RTCP feedback is just going to request for so many frames back. It's kind of a scope to launch amplification attack, as in.
No, sorry. This is not actually requesting frames back. What this is just
Okay.
This slide is just showing that I want feedback for this range of frames. It will one tag, like one feedback request will generate a response with one RTCP feedback message, which can have a status vector, which can contain like that range of frames.
Oh,
And just
okay,
like
okay.
from an attack vector perspective, this is like, it's between the two peers, and everything RTP is like all authenticated.
Oh,
So
yeah. Okay.
yeah.
I mean, I think
All right. Thanks.
that Jonathan is just interjecting the individual. I think there does need to be guidance on how much a receiver needs to remember.
Absolutely.
So the
We have an
maximum
open
size.
issue about this. Yes.
Okay, great.
Thank you.
Stefan?
So I'll spare you my video for tonight. I want to echo roughly what Mo said. I think trying to implement or trying to work towards a generic mechanism is too ambitious a goal. I think a lot of this looks like it would work well enough with AV1 and probably AV2. So maybe you want to go for a limited scope rather than repeating the mistake we have done in the past, frankly. and envisioning mechanisms in the future that relate to the future codecs that may not even have been set at this point, in the hopes to create a generic solution. So, I mean, we'll look at this a little bit closer once you have a working group draft, right? Because at that point, these comments may have a little bit more weight. But yeah, I appreciate the work here, and I have no objections in accepting this as a working group item. Thank you.
Thank you. So we have looked at this. Like we have similar mechanisms, proprietary ones in place for HEVC and H.264. So we know that like this can definitely cover that case. And we've looked at AV1 and AV2 as well. Yes, like in the future, if there might be a codec which we cannot fit under this umbrella, it'd be good to get eyes on the draft and get feedback about that.
Eric?
Yes, I just wanted to comment on this topic that we just had a comment on. I think that you can actually be codec agnostic as long as when the sender sends a group of packets with a specific timestamp and the marker bit to say this is a frame that you can decode. That is sort of the smallest unit we're dealing with here. As long as you have a codec that says if you have decoded this piece of data and marked that with a frame ID, then the receiver can say, I have decoded this piece of data, and then the sender it can use whatever codec it wants. It can be like part of a frame, even if it can decode a slice independently. And then it knows that, okay, the receiver has decoded this piece of the bitstream that I've sent. And I know the bitstream that I'm sending, whatever codec format it is, and then it can reason about which state the decoder is in when it comes to that part of data. Thank you. That's just my comment.
All right, yeah, Jonathan acts as an individual. I'm just, I think, somewhat reflecting what Eric just asked, but I'm curious how this works in the SVC case. So where you have multiple frames that have a single timestamp corresponding to the different spatial layers. Are each of those marked as different frames in this, or are they the same frame, and how does that work?
Eric, do you want to take that?
So in the case of spatial scalability, SVC, if you have multiple logical frames within a single access unit, so they all have the same timestamp, but they're different.
Those would be sent over different SSRCs?
No, same SSRC.
Okay. Eric, you want to take that?
Yes, so maybe I wasn't precise enough when I just said a timestamp and a marker bit, but the idea is essentially the same. Each frame, even when you're doing S modes, will on an RTP level be identifiable as that, like this is a decodable unit. And then to each of those, you can put one of these frame IDs as a sender and knows that when the receiver has received and decoded this part, and that could be then part of an SVC frame, that it will respond back that I have decoded this piece of data. And that's sort of essentially why also we want a vector of frames, not just like the last decoded frame. Because if you have multiple independent spatial layers within a single SSRC, you need to know the state of each layer independently to know what you can use as a reference or not.
Okay, thank you. Mo?
Yeah, I think Jonathan's question was really, do the timestamps, you have multiple frames now per timestamp, so your assumption that timestamp maps to frame, becomes invalid. So I think
I don't think this is making that assumption. I don't think this is making that assumption. I think there are.
So does the draft assume that timestamp has one frame?
No, it does not.
So you can have 10 frames in the same timestamp?
Yep.
That's no problem. Okay. And then to clarify, Eric, what I meant earlier is that I agree that the mechanism for the signaling can be generic, but for the mechanism to actually work, you have to have a binding to specific codecs. So how would you implement this for, 264 or 5, AV1, AV2? To have a full solution, you need to specify how this is used by those codecs and what, like 264 case, what MMCO message you send to be able to tag your frame with this frame ID and how that maps to the 264 frame ID. AV1 is even more complicated because there are bitstream frame IDs and there's also RTP payload format frame IDs that are different than the bitstream frame IDs. Now you have a third frame ID concept in this feedback message. So I think something that has to specify those bindings is needed to have a full solution. And yes, it can have a general, RTCP feedback message on the wire, but the whole solution needs, just like RPSI, bindings to the actual codecs to make it work.
Would be super
Yeah,
helpful. You could also get some comments on the GitHub with your thoughts on that.
Yeah.
you.
So again, speaking as an individual, I think an implementer needs to understand the binding between the codec specific frames and the and the frame numbers on the wire. But it's not clear to me that needs to be specified. I think that can be entirely a matter for. Mo, I'm actually responding to you. That can be entirely a matter for implementer innovation and development, and because the receiver is dumb, the sender doesn't need to. You don't need to have a deep standardization of how that works, as long as the sender knows what it's doing and does something sensible. Mm-hmm. And if it doesn't, it won't work well, and then you shouldn't do that. You should do something better. Mm-hmm. Any other comments? Are people generally, in favor of us doing a call for adoption here? Any objections to doing a call for adoption? All right, I see general nods for doing call for adoption, so we'll put that on our to-do to call that. I mean, I guess make sure that you have, I guess you've mostly working out of your GitHub repo, so make sure you have an actual draft published in the.
We have it.
Okay, good.
Yes.
So is that up to date with your latest version? Okay,
yes.
Yeah, great. All right, so it sounds like then we can do a call for adoption on that if with the version that you have published. Sounds good. Thank you.
Thank you.
All right. All right. So what do we have next? Okay. Next up we have S-frame, I think. Is that right? Yeah. All right. So Yuen, do you want me to hand you slide control?
Yeah, that would be good. I don't have a clicker, so.
Okay. Yeah. Yeah. You can just yes. All right. You should be able to.
Okay.
The slide.
Yep. Next slide, please.
No, I mean.
Oh, you want me to? Okay. Oh, yeah, that's right. Working. Cool. So it's an update. So we updated the draft based on feedback from last IETF meeting, and I'm presenting the current status. So the main change is that, as discussed previously, we added a new T bit type bit for either raw or prepacketized content. So 0 means raw as defined in WebRTC encoded transform, and 1 means prepacketized, meaning that you used a media-specific packetizer before doing encryption. We also have the pleasure to get a new co-author, Aaron Rosenberg, who was not there. Aaron is working on chips specifications, so the Matter effort, where S-frame is being used for camera streaming, and they're doing some stuff there as well. So they're using this draft in their specification and implementation as well. So with the new T-bit, we have like an asymmetry between sender and receiver, which is quite good. Basically, the sender has the freedom to do what it wants, use raw, use packetized, and how to split a frame, do per packet, per frame. And a receiver just follows the decision from the sender based on what it receives. So it simplifies API at the WFC level, and we hope that it will also help implementations. The spec now defines 4 algorithms. So there's a one generation of S-frame RTP packets on sender side, and then we have the per frame S-frame sending, which is what current user agents support. There is per packet S-frame sending that WebEx is using as well. And on receiver side, we just have one algorithm for receiver processing of an RTP packet. So that's about it. And the last thing that we added is per SSRC key derivation. So it stems from the chip specification, where they want to have a different encryption key for each SSRC. And so what they're doing is have a base key, and then you can derive per SSRC specific keys by using the SSRC as a sort to the base key. Here is the thing. And there's also a section on S-frame ratcheting integration. So S-frame ratcheting is defined in the S-frame spec, RFC. And the idea here would be to use the SSRC derived key as the base key for ratcheting. And so it's also described in the specification. It's of course optional. It's really up to the application, but it seems good guidelines, and I believe that the chips matter implementation will support these things. So that's everything we have new in the draft. We made some progress on WFC API side. So it's under discussion, but it's making progress. On sender side, we'll have support for either per frame or per packet S-frame sending. It's really the application that decides what to do. Plan is to have like a native construct, meaning that the user agent will implement the packetization, the encryption, and so on itself. And there will be support for per frame and per packet. And for GS support, meaning that you're doing the encryption using WebRTC encoded transform via JavaScript, support will be limited to per frame sending for now. And we'll see whether there's interest in extending the support. On receiver side, native support will be supported for per frame and per packet, and GS support will also be limited to raw content for now. That's where we are. Talking about implementation efforts, so there's lib data channel prototyping that is conducted as part of Matter Working Group. I don't have the latest status, but I think it's just working. It's limited to per frame sending and per frame receiving for now. It's not supporting per packet, but in terms of payload, and it's following the latest draft. We envision early WebRTC prototyping. I haven't checked lately where it is, but design decisions and are being made to see how we can do this effort. And I'm guessing that this effort will be used by user agents like Chromium and Safari in the future. We'll see. The idea is to support both per packet and per frame. That's the scope there. And finally, the last slide. So yeah, we want to finalize the document before going to last call. We think that although we have algorithms, we could simplify them a little bit. That's feedback we received. I'm guessing that we might want to add some guidelines on RTP header extensions in case of per frame encryption, or in case an SFU is refragmenting an S-frame packet. So whether you copy all RTP header extensions or not. So my guess is that we will probably do something like if header extensions are useful for packet switching, then they should be in all packets, but otherwise you do not need to copy them, basically. So something like that, I guess. And we cannot give more precise guidelines because it might be specific to each RTP header extensions. And we plan to gather implementation feedback. And once we have that, we might want to request last call. I don't have a specific schedule, but I'm hoping we can get last call before the end of this year. And that's it for the status update.
All right, thank you. Does anybody have any comments, questions, anything to say? All right, sounds good. Yeah, and that sounds like a reasonable timeline. Definitely, this is something where I would be happy to have, would like to have some implementation experience before we go with it, because it's not simple. I mean, it's simpler than it could be, but it's still, there's a lot there, and I'd like to know.
Yeah. The good thing is there are two implementation efforts. One on matter where you do not need to have APIs in browsers. So I'm guessing it will be easier and faster. The one still need to get WC APIs to get the full thing. So it will take a little bit more time.
All right. Sounds good.
Thank you.
Okay, thank you. All right, so next up we have, I guess, Justin, is that right? Do I have this right? Yes.
That's Philip's slides there.
Oh, that's Philip's slides. All right, let me stop that. Sorry about that. This one, stun for DTLS, is that right? And do you want slide control, Justin?
If it's easy, yeah, sure.
Yeah, all right, that should be, you should have slide control.
All right, you got the slides control. All right. Okay, so it's called Stun Protocol for Embedding DTLS, or short name SPED. So refresher on WebRTC. WebRTC basically sets up a sandwich of protocols. First, there's ICE that sort of establishes a valid pair, selected pair, and then DTLS runs over that selected pair. But these operations happen serially. First, the ICE process needs to establish that selected pair, then DTLS is then sent over that ICE connection. The DTLS handshake also has its own different semantics on how packet loss is treated. ICE basically has its sort of monotonic pacing. DTLS has exponential backloss. So the way that we try to solve this of not having ICE and DTLS run serially is we actually send the DTLS handshake packets as inside of stun by embedding them into stun attributes. So this can save an RTT. It works with all versions of DTLS. And with DTLS 1.3, which has a 1.5 RTT handshake, it actually delivers performance that's comparable to SDS, because we basically are getting all the DTLS transmission happening during the actual ICE process. And even more so, we get reliability under packet loss by using ICE for retransmissions rather than the DTLS exponential timer. Downside, now we have larger stun packets, and if you have a lot of actual pairs, you might end up sending bigger packets onto the network. But let's go to this ASCII art here. This ladder diagram, you can see the difference between the vanilla WebRTC on the left, where we have these things serialized. You send the offer answer, that's a round trip. You send stun binding request and response for ICE, that's a round trip. And then DTLS 1.2 has 2 round trips. So it's 4 round trips total before you can send any media. With SPED, we are actually embedding that DTLS into the ICE process. So we only have 3 round trips. In DTLS 1.3, as I noted, it's even better that the handshake has 1 fewer round trip. So we can actually, instead of 3 round trips with DTLS 1.3, we can get that down to 2. where the entire DTLS handshake is essentially covered in the ICE connectivity request exchange. So essentially, like I said, this gets us back to where we could have been with SDS. So we have our benefit of DTLS and have our cake and eat it too. The overall mechanism is fairly straightforward. We define a new stun attribute for carrying the DTLS packet. When you have DTLS packets that are pushed up by the DTLS layer to send them onto the wire, when the next ICE check goes out, it takes that packet and sends it out round robin across the ICE checks. We add a new stun attribute for an ACK mechanism. Then the ICE checks that are sent out will also include ACKs of packets that have been received using this mechanism. This ensures that we can acknowledge packets right away rather than having this exponential back off. There's no SDP changes here, no offer answer negotiation of this. You can tell just by the ICE checks, and if there's no attributes for the DTLS packets, you know the other side does not support this mechanism and you can stop sending. We have a few open questions, but the number one thing is, where should we progress this document? Anyway, that's the overall summary of the mechanism. I open it up for questions.
Harold?
So I would just note that Google has implemented the mechanism with a few divergences from what's in the draft. But yes, it works, and we definitely want to ship it.
Mo?
Yeah, I think this is a good direction. And one note on the larger stuns, I think that's actually a benefit because in the video case, we often see the initial rate estimate is very bad because of tiny stuns. And now if you get something that more reflects the traffic you're about to pump, you get a better rate estimate from your first round trip.
Interesting.
Gory?
I see a question about where you might want to do this. I think the first thing to clarify is that you do want to do this because it seems like it could be really useful. And then I'll talk with the chairs of this group and I guess TSVWG to see who should take on the work if we decide to do it.
Yeah, I think those are probably the two reasonable cases of groups that are still open. You know, it's for us, it might be a charter change. I'd have to think about it, but TSVWG might work. But then again, they're also there's a lot going on there. So, yeah, but I think it sounds like people do feel like this would be useful. Is there anybody who feels like this should not be done somewhere in the IETF? And if not, it sounds like we should talk with Gory and TSVWG chairs to figure out where it should be done. But it sounds like people like the idea. All right. Thank you. And
so
Gory,
can I check who might want to implement this? Because I think I heard you put the mic, but I wasn't quite sure.
I think Harold said that Google and Chrome is doing something that is similar to this. They're not exactly the same, and they think they would rather do something that was standardized. But I will let Harold speak for himself.
To be precise, our Jonas from Google has been developing this together with Fippo and Justin. And currently we have some disagreements on details on what the mechanism should be, but our goal is to converge on a single specification and ship that.
That is always a good input to have for an IETF work item. Thank you.
And we at OpenAI are implementing this into the Pion framework for Golang version of WebRTC.
Also good. So what I suggest I do is I follow up with the chairs here first, and we discuss the charter and where the best place is to put this work. And then a set of chairs will be able to do an adoption call.
Sounds good.
Great.
Thank you. Great. In that case, I think we can move on.
Turn it over to Philip.
Yep. To the other thing, which we don't know where it should go. But possibly the same. Oh, wait, no, that's the one we just did. So, hold on, I think I just shared the same one again. Hold on. This is Snap. Yes, there we are. And Philip, do you want slide control? No, he wants me to have slide control. I'm not sure we hear you right now, Philip.
Now it should be working.
Now we hear you, yes.
Okay, I'll let you drive.
Okay.
It's just 3 slides, so should be easy. Okay, next slide. So like the SPED stuff, this is something that sits between working groups. I think it's more of an SCTP topic, so I tagged it as TSV working group, but it does use SDP for the solution. So the question is, again, what is the right working group? I'll let the chairs figure that out. As a reminder, WebRTC uses SCTP for data channels, Data Channel Establishment Protocol RFC 8832. This runs over DTLS after ICE is done. And we think the time to open a data channel can be reduced in WebRTC. One way to reduce that is ICE and DTLS, that's the other draft. And this draft is about reducing the time to open the data channel itself. And DSAP already allows sending data without waiting for an acknowledgement. And we have negotiated channels, so you basically skip the whole negotiation when possible. Next slide. So again, ASCII art on the left, we have the vanilla WebRTC case, SDP offer answer 1 round trip, ICE 1 round trip, DTLS 1.2, another 2 round trips. And then SCTP does this init ag cookie and cookie ag, which brings us up to 6 round trip times. And we can reduce that on the right side to 4 by skipping the SCTP init. Next slide, please. And what we do is we basically take the SCTP init and init ag, which are either 1 or 2 RTTs. The spec says it can be 1. What I've seen in implementations in WebRTC was 2. We do this with the upfront SDP exchange. We basically take the init chunk base 64 encoded and put it into a single attribute in the SDP, which is reasonable because we only have a single SCTP M line. So it doesn't blow up the SDP size too much. It still does feature negotiation, which kind of fits the SDP purpose. And from there, you can jump straight to data channel establishment protocol or negotiated channels. We do have 2 implementations, one in libWebRTC and Chromium. This is still behind the flag because we want to avoid shipping it without getting IETF eyes on it. Same for Pion, we have a SCTP and WebRTC implementations pending, waiting before merging and shipping that for some feedback. Does anyone have questions?
I'll ask a question as an individual, Jonathan Lennox. So I don't know how much the implementations actually support it, but in theory, I mean, WebRTC doesn't. I think in theory, WebRTC kind of supports this, as I recall, but there's the issue of what happens if the offer is forked. Is the SCTP init, so you're sending the same SCTP init to more than one destination. Is that going to be a problem?
I think it will always end up with a single offer answer pair.
Yeah, so the answer, there'll be so a single offer might have multiple answers. Then you have in theory.
That's a good question. I need to think about it.
Okay. Justin?
I was thinking that the DTLS connection would only be established with like a single remote peer. So I think it's probably not likely to be an actual issue in practice. And even if it is like decided, if it is parallel forked, I think that the init packet would still be valid nonetheless.
Okay, I don't know enough about SCTP to know if that has randomness in it or anything like that. Harold?
And the problematic case is, of course, peer answer. Sigh. But if you get a peer answer with one init response chunk and then an answer with a different one, I don't know what state you end up in. And when you get a peer answer and an answer with different signatures, that just causes an ICE restart. It's actually used unfortunately, actually used in practice to have handle multi-answer situations. So peer, we could just say no to SCTP init in peer answer. That would be tempting, but we probably need to address it.
Magnus?
Yes. Yeah, I think the problem here is, you say, if you get multiple answers, you really need to know that you're binding the SCTP init ACK to the actual endpoint you're establishing the ICE connectivity with, so that you actually can continue when you come to the DTLS with the cookie echo, cookie ACK. Otherwise, it will not work, because I mean, this does carry SCTP configuration data. There could be potential differences in parameters, etc. And also your set of your building of the V tags in the packets. To match the second round, you need to have the first round be matching. So I think it's you have a problem here that you actually need to understand that you're talking to the same endpoint that you exchange the offer answer with when you come to the post DTLS part.
Okay.
But yeah, otherwise I think this is fine. I mean, init ACK is intended to be stateless on the server side, or saying the responding side for the SCTP. So it should be able to take the cookies that's sent in this and verify it works. Otherwise, you would just get the SCTP renege. Nope, this doesn't work. Abort. Go back. So I don't think it's if you actually screw it up, you would end up in saying, oh, you as a client is going to have to renegotiate, initiate, do a new SCTP init on the DTLS connection.
So if you do it wrong, it costs you round trips, but it doesn't mean you don't set up.
Assuming that you have an implementation that will, when it gets an abort from the server side, that this cookie doesn't match what, it's not for me, I don't understand it, it's not for me, and do an abort, that you actually do a new init.
Corey?
Yeah, same sort of answer to the previous question of which working group. Let's discuss this, but it looks like this needs discussion here in AVTCORE to work out what exactly is being proposed. Although I really suspect that any work to change SCTP should be done in TSVWG.
Yeah,
but please discuss here.
Yeah.
Go ahead.
The main issue is that I think a lot of the complexity comes out of the SDP parts, which is, not if M music still existed, I would say this would definitely be an M music, but it doesn't. So I'm not sure who has inherited M music, and arguably it's TSVWG, or arguably it's us. But I think certainly anything that needs a lot of SCTP knowledge is going to be TSVWG, but there's not a lot of SDP knowledge there. So it's tricky.
Well, okay. This is why the IETF exists, and we'll figure out how to solve the problem.
Sounds good.
If it's what people really want to do, we'll find a solution.
Yeah, and it sounds like certainly there's interest in this. I would say, but Magnus, did you have more to say?
Yes, Magnus Westlund. I do think it's primarily mapping, and it's primarily a question of how SDP offer answer interacts combined with the kind of ICE procedures, etc. It's the SCTP parts is probably fairly straightforward. It's not really changed. It's just that you move the message from one place to another, which has some implication of what could happen. But I think you can actually explain it. Oh, this would be corresponding to the following thing happen on an IP network. If you would try to talk to another client, it's basically say, oh, I'm sent the wrong thing to the wrong server, and that's what's going to happen. So I think it's not necessarily so much SCTP. You definitely need SCTP knowledge, sanity eyes on it, but that's, I think, is by inviting, getting like Michael Taxon also to look at this, etc. It's probably better to do it, focus this in music / AVTCORE land kind of part. I mean, so.
Yeah, agreed. All right. Is any other comments on this draft? It sounds like, I would say there is interest in doing it. We still need to figure out where, but it might be here. It might be that if we do it here, it will require some charter updates, but that's also something we could take care of if necessary. All right. Any other comments on this topic or any other business? I think this is our last presentation, unless I have forgotten something. All right. In that case, I guess let's go over what the chair's work items are. And let's see. I think we said, Marius, you have notes there, or should we?
Yeah. So for the RTC profile, we're gonna issue a last call once the new version is published. For frame acknowledgement, I think we can start a call for adoption as soon as the current one runs out. So I don't think we have to wait for that. And for the last two presentations, we have to figure out where to put this. I think that's all that we have to do on our end.
Okay. Did we say we were going to do a working bus call on? Oh, no, APV still has some work to do, right? So. There.
Yeah.
So I'm trying to think. Was there something else you said we were ready for working bus call, or am I misremembering? We said.
I don't think I haven't recorded anything on my list.
What did we say about ARF? I can't remember.
Let me see. I haven't recorded anything about ARF.
What? Okay, if you want to come to the mic, Joe.
We will request it later. Yeah.
Say again?
We will request it later. I mean, maybe after we.
Oh, right. We're waiting
Yeah.
on the MPEG.
Yeah.
We're waiting on the MPEG updates. Okay, perfect. Thank you. Great. All right. So I guess we will start. We have our work items of the chairs. Should expect those in the next few bits. And as usual, probably expect an interim sometime between, roughly halfway between now and Vienna. So I guess that'd be probably May, I would suspect, though we'll need to figure out what works for people. All right. Thank you all very much. Any other business? Otherwise, we can call it a day, and you can wander down to, or those who are here in person can wander down towards the snacks in the plenary. And everybody else can go do whatever is appropriate for their time of day, whether that's, finish their day or get some sleep or whatever. All right. Thank you all very much.
Thank you all, and enjoy your snacks.
Yeah. Yeah, I think ours, often we give time in case something, something happens, and then, everybody says, oh yeah, let's do it. They don't really talk about it.
Thanks for your inputs, Mo.
Especially
Appreciate it.
Because, everybody's going to implement it.
Yeah.
If everybody has to implement it on their own, they're gonna maybe implement it differently. Or even if they don't implement it differently, they have to all repeat the work, all repeat the same work.
I think that's what we were discussing. Oh yeah, they have to repeat the work to figure it out.
Yeah.
But does it different people can do it differently and not be.
Yeah, I mean, I think, yeah, I guess my point is there's no interoperability concerns. I think that's sort of yes, people have to figure it out, but that's also an opportunity to do something clever.
Yeah, as long as the sender says this is some frame and I am able to tell it yes, I've decoded this frame, how it manages that state is completely up to it.
I think that the solution to everybody has to figure it out is to do it in WebRTC so you can look at the source.
Yeah.
That's what open source is for, not what standards are for.
Code is a spec.
Yeah, or not. It's not a spec. It's it's how you do it. Yeah, and this does allow for somebody to come up with innovation of, oh hey, I can do this other clever thing. You don't have to come back to the IETF to do that. You just do it.
Otherwise, I think we'll have to start mandating every new payload format which
this
has to also now start.
Yeah, that's sort of the problem with RPSI, that every payload format has to say how you use it. So yeah, and that said, I think, as Eric said, some non-normative examples of how you could use it
definitely
would be very helpful.
Just get some examples into this draft. I think that would be cool. But trying to do that for every codec.
Yeah, I agree.
But I still didn't get how you tag things as a frame if they're not known.
Well, there's a
to the
header
timestamps.
There's a header exception. There's a header exception that says this is frame 1, this is frame 2. It's very simple.
So every packet.
Or every packet that has a frame you care about.
Yeah,
So
yeah.
so every packet that has a reference frame that might be interesting to talk about has a header exception.
So I was confused. What does timestamp have anything to do with your illustration?
He just had timestamps in his illustration to talk about which frames are which.
Exactly. It's just when you want to say references, this frame is referencing this frame. I needed some identifier which is not frame ID. Because that was the only reason timestamps are there. The spec actually doesn't even the draft doesn't talk about timestamps at all.
Arbitrary tag every packet with a number.
Yeah.
And then the decoder says, or the receiver says, I got this number.
Yeah.
Okay. So why not just stick with RTV sequence number then? Why do you need a
because
frame number?
there's smaller numbers, don't cycle as fast. And so in the sequence numbers, you have to talk about the whole range. I got this one through this one.
Yeah.
But I mean, this one you if it's all the same frame, it's all gets the same number.
Yeah, you don't have to add it to every packet. You can add it to just
the first
yeah.
packet or something of a frame.
And even in the example, say if there's a slice or something which you want to deal with separately, you can just add it to the first of that slice and not.
Wasn't RTP ACK originally using sequence numbers? The old ACK.
Yeah, I think so. But
that seems like it's
like that, but it's lighter weight than that, I think. So.
I mean, there was also talks about like RTX and stuff, where like
Yeah, I
mapping
think
the sequence numbers back into like frames can be very like.
Yeah, I think there would probably need to be some.
But you already have that problem now because you have to map the frame ID into frame, right? When you say frame, you mean the complexity of knowing the codec actual frame, or you mean
yeah,
the RTP sender packetized as a frame?
Yeah, the sender packetized as a frame.
Yeah, so, I mean, I think there might need to be some discussion. I don't know if it's normative of like how you should have this interact with like RTX and FEC. Like, should you, how long should you wait before I mean, it's like if you say, I guess my point is like, did you get this frame? Well, do you want to wait for the RTXs to?
I mean,
to
right
have
now
some-
it's
have a
about
chance?
like decoding a frame.
Uh-huh.
So you're kind of saying that I decoded the frame, or I'm certain I'm going to decode a frame. You don't have to
Yeah.
wait till the decode actually happens. But so that implies that like the RTX and FEC has
Yeah.
already been applied, and now you're.
Yeah, but I guess if you're only putting this marker in the first packet of the frame, you ask, did you decode this frame? Can you decode this frame? It's like, I don't know yet. I haven't gotten all the packets of it yet. So
Yeah, I think you have to at least receive all the packets.
yeah.
either
So
through
how long
RTX
do you
or
wait to
FEC.
decide you have it before you send the feedback?
So that is the like SDP parameter that we
Oh,
introduced
okay.
for like a resync timeout, where you
Okay.
can define that based on your use.
Okay, that makes sense.
I still kind of think that maybe you want to rethink whether you should just do this the old ACK way and just use sequence number instead of.
Yeah, I think the first version of this was using the I think the 81 dependency script frame numbers,
Yeah.
but I think they decided it would be better to have this standalone.
Yeah,
depending on something else.
But I mean, at the end of the day, I think the thing you actually do care about is the RTP sequence number. I think that's the thing that you're trying, because like the same for RTX infect, those mechanisms are also sequence number based. All the FEC payload formats, embed RTP sequence number ranges in them. RTX embeds the RTP sequence number ranges in them. So there's going to be interaction with RTP sequence numbers everywhere.
Yeah, but I think I personally prefer having a separate, its own standalone thing rather than trying to reference. Because sequence numbers is, if you're talking about whether you decoded a frame, talking about that in terms of sequence numbers is a little weird.
Oh, this is I decoded and the decoding worked,
Yeah.
not just delivered, not RTP receiver received.
Yeah.
I decoded and the frame had no problem decoding. I had all the dependencies for the frame and everything.
Yeah.
Oh, okay, that's a different thing.
Yeah.
Okay, I thought it was just RTP receiver.
No.
Is acknowledging that it received this payload.
I have successfully decoded this frame.
Okay. There's a slight nuance that most decoders don't actually know.
Well, there's you usually have infrastructure before the decoder to say, can I, yes, usually the raw decoders will just happily say whatever's in reference. I'll
garbage.
Yeah, I'll do this based off whatever's in reference buffer 3, whatever. Here you go. But yeah, usually you have
I know Eric at some point had like another draft going where you could detect that by sending.
Oh, I saw that.
Yeah. So I think that's why you put all of the both things together.
Yeah. I remember that. That was,
Okay, yeah, then I see why you want different sequence numbers if you want guaranteed, if you want output of decoding, not input of decoding.
Yeah.
That makes sense. Yeah, I think I'm fine with let implementers be clever if they want to, or let them be forced to scour code to find examples.
Put some examples in there.
Yeah. Yeah, and I think certainly especially to clarify things like if you're using a structure with an SVC or something like an IPPB, then you don't put things on the V's, and that's